Hey, Ladislav.
Hello.
Oh, yeah. Annoying, 'cause I forgot to push, the record button, and we missed an entire part about the cookies. What was the name of the cookie?
So the cookie we talked about at length was Żybowskie honey
Yeah,
in Czech.
which you baked for Christmas, and this is only available in South Bohemia.
Bohemia. Yeah, that's
Bohemia,
right.
yeah. And we had a chat that you try to adjust the right size of the cookie, and now it's the task for the listeners to to find more about the cookies, whether they are available somewhere else or only in South Bohemia. And what we did with a chat about the history of CDI. Because you are now working on the CDI specification,
Mhm.
and what I try the last 10 minutes to explain is that CDI annoyed me, not CDI, dependency injection was a huge hype, I don't know, 15 years ago or 10 years ago. And I was a little annoyed by that because for me, it was a natural step in the right direction. So if you just implement backends or Java code, in one point of time, you will find the factory pattern or abstract factory pattern. And the idea is to implement or to instantiate classes which implement an interface and then return the interface, and you do it over and over, the instance, and you do it over and over again. In one point of time, you might ask, what if I hide the factory somewhere, and somewhere was the server? It would be the application server, the runtime, Quarkus, OpenLiberty, Payara, or Whitefly. And if you do this, now the question is, okay, the runtime does that, but how the runtime have to pass the instance to you. And there was so-called Hollywood principle: don't call us, we will call you. So it means if you are good enough, you become the next actor. So, or the server will give you the implementation or the instance at the right time. And then the first attempts were with XML, which I didn't appreciate at all. And it started, I think, in Java E5 with @EJB, and with Java E6, CDI was introduced, context and dependency injection. And so the instance was passed to the server, and you had to use the @inject annotation to mark the attributes. And this is how the server find about that. And the problem with this is that how to implement such a thing. So usually a deployment time on application server. So there's what happened back then. You had a war or EAR or EJB jar, and you copy it over to a folder. The server found the archive, extracted the contents, and instantiated everything, but now tried to find the @inject stuff. And he usually what happened the following: the server invoked class get declared attributes. You got an array of attributes. Search for is annotation present with @inject. If it was instantiated, use the factory to instantiate the class, and we were ready to go. So this was the brief introduction how dependency injection happened. And CDI is I would say, one of the most powerful one. And it comprises two parts: context, which we also will introduce, but dependency injection is what I try to describe right now. And interesting fact is that @inject was not part of the Java E first. So the first Java E dependency injection was @EJB, only worked with EJBs. And then at the same time, there was a framework called Seam from Red Hat, which was really powerful. They had inject, outject, and biject. And this was in and out annotations. The biject, I think you had to annotate both. I don't know whether there was biject. And the outjection was like produces in CDI. This inject is like is in. But interestingly, or unfortunately and unfortunately, at the release time of Java EE6, Spring and Crazy Bob Lee, they introduced an alternative approach with @inject JSR 330, and this was a very small. I remember within 6 weeks or 12 weeks, so it was incredibly fast specification. And what they introduced was an @inject standard without PDF. It was just a Java doc, and the main annotations were @inject produces qualifier produces as well, right? Ladislav?
I'm not sure.
I'm not sure about
produces is in CDI.
Yeah. Then a qualifier maybe?
Yeah, at inject, at qualifier, at named.
Named, exactly.
Singleton.
Yes.
And that's probably it.
Yeah. And this is why Java 6 was delayed, because it was reincorporated. So it means the entire Java 6 specification, all the servers are actually working on Spring-based annotation called @inject. So it's absolute standard, double standard. Okay. And you started to work on CDI 4 a few years ago.
Yes, that's right.
Yeah. So we made up some time. So we didn't cover the cookies in depth, which is a pity. So, but it was a nice conversation. But CDI, now we are up to speed, right?
Okay. Yeah, I'd like to repeat one thing that I think is important. There's a parallel between the @inject implementations and CDI implementations that I made in an article on the Quarkus blog about the history of CDI 4.0.
Mm-hmm.
One of the most popular implementations of @inject was Juice, made by Google. That's a runtime-oriented implementation. And another, and that's like akin to Weld, which is like fully runtime-oriented implementation of CDI. But there's another implementation of @inject called Dagger, which is also made by Google in its second version, and it's like fully built time-oriented. Pre-computes all dependency wiring during application build. And that's what we wanted to achieve with CDI 4. We wanted to be able to implement CDI during build time. Mm-hmm. There's a few concepts in CDI 2 or 3 that precludes that. Mm-hmm. And one of the most important ones was portable extensions. Mm-hmm. There's some, we probably get to that, but there's a few things about portable extensions that just don't make it possible to implement during build. It has to be at runtime in the same process that will later execute the application. Mm-hmm. So that's what we excluded from CDI Lite. Mm-hmm. That's the biggest part. We also excluded a few other smaller things, but this is the biggest part that we excluded from CDI Lite. And there was a topic of a big conversation. Should CDI Lite even have extensions? Mm-hmm. And like there were many opinions, but ultimately we decided that we have to do that. Mm-hmm. And that's where I became involved, basically.
My opinion would be, if you're building a server or platform, so such portable extensions could be useful, like plugins. But if you're building business applications, I don't think they are useful. So I reviewed a lot of business applications. I never used portable extensions in any business application.
I mean, you mean you never wrote one? I guess you probably used a few, but you never needed to write one.
Yes.
Yeah, that's right. And I mean, portable extensions are like a crazy powerful mechanism. It allows you to change like practically everything. It allows you to break your applications in many kinds of ways, but it also allows you to do many very powerful, very interesting things that the application builders might wanna access to.
As I recall, what you can do, you can at runtime, at boot time of the thing, it could be build time or whatever. You can add annotations or metadata, not annotations, metadata to classes, or not only classes, to to elements, right? It could be class, it could be attribute, it could be method, and then react to it. So I can say whatever ends with, let's say, service gets automatically annotated with request scoped and transactional, for instance.
Yeah, that's right. Yes, you can do things like that. Yes.
Yeah. And this is really hard to debug, because you can depending on the clock time, have different behavior and annoy the developers, if you like, right?
Yeah. If you're a mean, evil person, you can do things like that. Yes.
Yeah.
The most important, what the thing that makes it hard to debug is that it doesn't appear anywhere. Mm-hmm. These additional metadata, these transformations, they don't appear in the bytecode. they only exist in the memory of the CDI container. So they can be very hard to debug. Just like why you don't want to use too many of them or even write. But at the same time, they make things very powerful. So yeah, it's always a choice that one has to make.
Yeah, what you could do with them, you could create an application framework which is fully based on convention over configuration.
Yes.
And just use naming conventions, and you have just Java POJOs, and if you name them properly, everything works, right? So it will be the simplest possible Java framework. But of course, you have to stick to the conventions. Yeah.
Yeah, that's right.
So, and what we didn't cover at all is the C, is the context. And to my understanding is if we build our own factory, we have to decide how many implementations and when they are created. And in the CDI Quarkus case, it works like that every request is request scoped. You can have a new instance per request, new instance per application is application scoped, and a new instance per session, which is less common. This was the HTTP session, and session scoped, and you could have conversation scopes, which were sub-scopes of a session. And what I think is session scoped and conversation scope are great extensions for LangChain4j and for memory of the LLMs, because what you could do with that, you can have a standardized, chat memory with a nicer name, but it was solved differently. But I would say, if you think about this, the HTTP session and LLM session are very, very similar.
Could be. I don't know. Yeah. I honestly don't know almost anything about LLMs.
Oh, then very briefly, maybe to also to the listeners. So LLMs are stateless. So if you ask a question, you get the answer. And if you like to have a follow-up, you have to remember the entire thing and send it back and forth. So what it means is you need a kind of a conversation ID or whatever. So that, there's not mix between users. So then your conversation is your conversation and the other user conversation is other user conversation. If you ask me, very similar to HTTP session back then. Mm-hmm. And one user can have multiple conversations, which is conversation scoped. It is exactly how it was supposed to be for different purposes back then.
Yeah, the conversation scoped in CDI is like there are certain APIs that come with that. I'm not sure if they can be implemented fully with LLMs, but
the concept is similar, right? The concept is similar.
Sure. Yeah. Yes. Yeah. Sure.
Yeah. Okay, so we even clarified the C. So there's and what's a bit confusing, application scoped collides with singleton.
Yeah, that's a fairly often asked questions in the Quarkus area. Which one should we use? Should we use singleton? Should we use application scope? There's a section in the Quarkus documentation that details the differences between singleton and application scope. There's a few. Singleton is a pseudoscope, so it doesn't have a client proxy. So if you while application scope is a normal scope, so there is a client proxy. So if you if you inject an application scope bean, what you get in fact is a client proxy that lazily obtains the actual instance and delegates to that on each method call. So there's a bit of an overhead there. While as a singleton, you get ejected directly the instance, and you can access it directly.
Mm-hmm. Maybe the proxies, because also interesting concept for the listeners. The crazy part is, what I could do is I could start with application scoped bean and expose it to the user, and inject into the application scope, which is basically a singleton, request scope bean, and it will work. So it means the application scope will be only one, but per request, for every request would get an own instance of the request scope bean. And this is only possible with proxies. It means the proxies are like load balancers. They're dispatching between the instances. And what you are saying right now, if you would use the singleton, there are no proxies, so this won't work.
Yeah, that's right. That's right. So typically we have only two kinds of pseudoscopes. We have singleton and we have dependent. It's like a complete opposite. You have a new instance for each injection point, and everything else is normal scopes. Mm-hmm. So in CDI Lite we have just request scoped and application scoped. We excluded the session scope and the conversation scope from CDI Lite.
Mm-hmm. So what I'm doing in my project is my first facade, let's say, is the application scope or request scope, and everything behind this in business application is dependent scope. So it means it is controlled more or less by the first class. So I have only one annotated class, application scope, request scope, and all the others have dependent scope. In Quarkus, they have to be annotated, but sometimes I use business annotations with no meaning, just annotation. And this is how it is managed by Microprofile. And now you introduce a new term called CDI Lite. Yes. What is it?
Yeah, so CDI Lite is a part of core CDI that we introduced in CDI 4.0. Mm-hmm. So I think I said already that actually I didn't. The major goal, as I see it, of CDI 4 was to be able to implement CDI at build time. Mm-hmm. So we had to preclude a few parts of CDI, notably portable extensions, and that became CDI Lite. CDI Lite is 80% of the original CDI. Mm-hmm. The biggest part that isn't in Lite is portable extensions. There's a few parts of. So the core CDI specification became or was split into CDI Lite and CDI Full. CDI Full is still mandatory in Jakarta EE implementations. Mm-hmm. So in Jakarta EE you still have all the CDI you had before. There's no change there. But for more restricted platforms such as Quarkus, they can only implement CDI Lite, which is what we do. We actually implement CDI Lite with a few extensions from CDI Full. Mm-hmm. And CDI Lite, I think I would say it contains 80% of the original core CDI. It doesn't have portable extensions. It doesn't have session scope and conversation scope. It doesn't have specialization and decorators. And it doesn't have the full Bean Manager API. Mm-hmm. It has a subset, a sizable subset of the Bean Manager API. And I think that's it. The biggest, the most part of CDI is still in CDI Lite. Mm-hmm. You have all the dependency injection, context, events. You've got programmatic lookup. I don't know what else. But most of it is still there.
It's also the JVM bootstrap or JVM boot. So the possibility.
Oh, you mean CDI SE, the SE container access? That's not in CDI Lite.
Okay.
Because again, that thing is heavily runtime oriented.
So this is part of the full then.
I think actually it's not part of core CDI at all. It's above the core.
Okay.
Right. So the CDI specification is structured or was structured in 3 parts. There was core CDI. Mm-hmm. There was CDI in Java SE, mm-hmm. which is the SE container initializer, and 3 there's CDI in Java or Jakarta EE. Mm-hmm. And what we implement in Quarkus, just the CDI Lite part of the core.
Okay.
So we don't support the SE container API.
And you know what happened to Java SE, because of an interesting concept. I think Weld implemented that, but
yes,
it's interesting whether there is a standalone reference implementation as well. Mm-hmm.
Yeah.
Okay, and the implementation of Quarkus is called Arc.
Yeah, that's right. Yeah, mm-hmm. That's. It's typically written with capital A and capital C. Mm-hmm. So well, a little bit of a joke. When I first heard of it, I thought, well, that surely means a reduced CDI. Mm-hmm. It's not the case. It's a reference to arc welding. There's I couldn't never endure in it. But the original author of Arc was previously a maintainer of Weld, so there's a direct connection between those two projects.
Yeah. And can Arc be used standalone without Quarkus?
So that's a question that we sometimes get. The short answer is it is theoretically possible, but we practically wouldn't recommend it because, and the only reason we wouldn't recommend it is there's no tooling for that.
Okay.
There's a sizable integration API that the integrator has to use and has to perform certain parts of CDI Bootstrap to be able to use Arc. Notably, the integrator has to perform type discovery. That's a term, specifically from the CDI specification. The CDI Bootstrap consists of type discovery, bean discovery, running the extensions, basically. Right? And in Arc's case, we left type discovery to the integrator. Right? And we don't expose any pre-built type discovery implementations outside of Arc. So the Quarkus extension for Arc does type discovery on its own. And if you wanted to use Arc standalone, you would have to do that on your own. And it's not a trivial task to do.
Yeah, I understand why. Because the Quarkus extensions, no, not the CDI Quarkus extension, there are two parts, is the build and the runtime. And this is how you do everything, right? If you have a JDBC driver, there is the build part which optimizes and the runtime which runs the extension. And the same is probably true for Arc, that you have the two parts, and the build time extensions provides the type information because Quarkus has the infrastructure to scan the types and provide information, right?
Exactly.
Okay. So it's not evil Quarkus. It's more like this is the Quarkus architecture, and Arc is just the dependency injection part without any additional discovery mechanisms and convenience functions, right?
More or less, yeah. It's a bit more intricate, but from 99%, you're right.
How big is Arc? So how many classes are there? Very interesting to know. So roughly,
it's not terribly huge. It's not a small project either.
Okay,
but it's not terribly huge.
Okay.
I think there's 100 classes.
Okay.
In the processor, which is the build time part of Arc, and what about 50 classes in the runtime part, something like that, ballpark figures.
Okay.
It's not terribly huge, but it's not small. And some of those classes are fairly big. That there are especially classes that generate bytecode. There are a few thousands lines of code each.
The bytecode generation.
Yes.
Okay, yeah. This is because what Quarkus does is actually code generation on steroids, right? So what it tries to find out is the metadata and uses the metadata to generate simple bytecode. Simple means no magic bytecode, so it boots fast. So this is the
that's
secret
right.
sauce.
There are we do magic, but we try not to do that too much, and we try not to do that at all in Arc.
Okay, so now you are the CDI Lite, how to call it, a contributor or even leader? Are you
I'm not a leader in any formal kind of sense. I built most of the API that we added in CDI 4.0 and 4.1. But I'm just a regular CDI committer.
Oh, committer. Okay. Just a regular committer. CDI committer.
Yeah.
This is actually a good title. Just a regular CDI committer. Okay, cool. So we have now CDI 4.1, I think, right?
Yes.
This is the
that's the release for Jakarta EE11.
And what is the relation between this and Quarkus? Are you tracking this, or do you need features, or no? How is it working? So because Quarkus is a subset of Jakarta, which is of course natural.
A small one, yes.
Yes. Let's put it this way. I was able to migrate most of my older Java EE projects to Quarkus without any trouble. But it's a small one because, something like JCA is actually not required in Quarkus or JSF, and there are huge specs which are not supported by Quarkus. But usually, if you are building a Java API, backend API, REST API, you don't need them, right? So it's like, or SOAP, for instance.
We actually have extensions for both specs you mentioned.
Yeah.
There's an extension for JCA using the Iron Jacamar project that's also used in Wildfly. There's an extension for JSF, I think, at least in my faces.
Yeah, it works. JSF is running on Quarkus, but it was not available from the beginning, and there was no focus on it, right? So
that's right. The JSF extension is an external work. I think the my faces people build it. The JCA extension was actually built by one of our own people, George Castaldi. It lives in Quarkiverse. So we do have, but the core Quarkus implements just the Jakarta EE core profile. It's like CDI, JXRS, and I think perhaps the JSON specifications.
Yeah, JSON
P and JSON-B.
And bin validation as well. So this is...
Yeah, that's right. Yeah, and JPA. Yeah,
and config, microprofile config, for instance, in all the microprofiles.
And we have all the microprofile specs, yes. Yeah, that's right.
But funny enough, all the microprofile specs were available on all application servers as well. So for me, I never distinguished between microprofile and Jakarta EE. This was there. I just used that, right? So for me, it was the the entire conversation microprofile of Jakarta EE. So it's pointless because Payara, Whitefly, everyone supported both actually.
Yeah, that's right.
Yeah. Okay, cool. So now, so what we already clarified a bit is what CDI is. What you also mentioned is stuff like specializes. And maybe very briefly, I would like to introduce the ideas of CDI and what you can do with CDI. You can introduce your own hook or factory called with produces. And what happens then? You can just annotate a method with produces, and Quarkus or a runtime will call the method to create bean. So this is, for instance, you can do non-standard stuff, call the constructor first and set as and whatever you like. You can integrate. This is actually my way to integrate, this was the replacement for JCA connectors. Because if you have the producers, you could do ugly stuff there, create whatever, wire up the entire thing and return it. And this was my way to integrate external stuff. Then specializes was actually interesting. What the specializes, you can override beans, right? So if you say specializes and you extend from other bean, this bean is taken instead the super bean. This was specializes. And you mentioned something different. What was not available?
Decorators.
Decorators is like interceptors, right? But with interface.
Yes. Well, it's like interceptors, but it's like the complete opposite. Right, where interceptors are like agnostic of the code that they intercept.
Yeah.
Decorators are, on the other hand, like intimately aware of what they are decorating.
Yeah. So you would inject the decorator, and then the decorator will call you, right? So this is like this interface to implementation, as I recall, right? So you have an interface.
You can have an abstract class as well.
Okay. I use mostly this interface. I recall there was interface implementation and your implementation, and the decorator was injected and could call you. You could you could inject your to the decorator.
Yes.
Without ambiguous dependency error, right?
Yeah, the delegate. The delegate. The decorator delegate, yes.
Delegate, exactly.
Yeah, we actually support decorators in Quarkus. It's like we don't run the decorators part of the CDI TCK, but we support a sizable portion of decorators API.
And why decorators are not supported in Light? Because this is easier to support than Interceptor, right? From the runtime perspective, if you think about this.
So that's That's something I would have to investigate to be able to tell you.
Because if you think about this, the decorators are simpler to implement the interceptors, right? Because interceptors involve dynamic proxy or because this is a complete reflection. And decorator is just preventing ambiguous dependency error. And you say, pick, the
No. Both of them have the similar. Well, at least in our implementation, they are both fairly similar in that, like, we generate a subclass of the intercepted or decorated class. We
like proxy.
Yes, yeah, it's
more like proxy, right? It's a standard.
Yes.
Standard.
It could be implemented differently, but we implemented it this way because it's the easiest way.
Mm-hmm.
And we actually support both at the same time, I think. I honestly don't think that one is easier or harder than the other.
Okay. I thought that the interceptors would be easy. So harder to implement for the runtime. And
for all cases, we know who's the or what class is the entire, like, the ultimate target of the invocation.
Mm-hmm.
And we pre-generate those classes so that we don't have to reflect on anything. Like, for interceptors, we do have to use reflection to be able to satisfy the invocation context API,
mm-hmm.
which gives you access to the Java-line reflect method
mm-hmm.
Of the intercepted method. So we have to we do have to use reflection there just to be able to satisfy the API. But other than that, we just pre-generate the invocation to the ultimate class.
But if you will implement, the light from scratch. So for interceptors, what we will need to do is, so the easiest one will be to generate, an interface maybe for a class, then use dynamic proxy, because without interface there's no dynamic proxy, and then you can intercept the calls, right? And what you will have to do is to pass it to invocation context. You said, right? Invocation,
mm-hmm.
and there's I forgot the method name.
Proceed.
Proceed with around invoke, I guess,
mm-hmm.
was the annotation,
yes.
And invocation context was the parameter,
yes,
and then was called the method and so forth. And this is somehow reflective. Reflection doesn't have to be used in behind the scenes, because on interface you could do whatever like, but this is more or less reflection-like. But the decorators, on the other hand, I think you have an interface or abstract class, you said. I could have two implementations, which are type-safe because they have implement all the methods, so I know the method in advance. So what happens behind the scenes, the decorator is injected and delegates to my implementation. So I would say this is like stock DI without any magic. So for me right now, so from outside, if I would implement that, it's easier. And you're right, you have to inject proxy because there is scopes, so context, so you have to do more than that. And also, the decorators can be intercepted, I guess, even. So there's there has to be some intermediary or proxy level. But it's strange, then they removed the decorators and kept interceptors. So this is what
I think the reason for that was that interceptors are a lot often used than decorators.
They are.
We had interceptors support since the very beginning.
Mm-hmm.
We added decorators only after a few users asked for them.
Mm-hmm.
Just that really took a bit of time.
Mm-hmm.
So decorators are way less often used than interceptors.
Okay.
That's like the only reason.
Mm-hmm. And portable extensions are not part of the spec, CDI Lite spec.
Yes.
And what portable extensions are is you can attach to any element. It can be, is it called actually element the right thing? So if you call it, the right way from reflection perspective, class, attribute, or method, is it element?
Yeah, I think in this spec we call it program element.
Program element. Okay, you can attach to any program element whatever annotations or metadata you like. It doesn't have to be a metadata. And of course, if you attach request scoped annotation to a POJO, Quarkus will notice that, and this POJO will be request scope bean. So this is how portable extensions are working, right?
More or less. It's just one. It's arguably the biggest part of the portable extensions API, but it's not all. You can do a lot more things with that. You can affect the bean discovery. you can register custom annotations. Like you can take an annotation that is not a qualifier and make it a qualifier. I don't know why anyone would do that, but it's possible. You can register custom scopes and contexts. You can do custom validation if you wish. That is actually a fairly interesting thing. If you're doing a framework on top of CDI, like as you mentioned, a framework based on naming conventions, you can do validations and fail if something isn't like correctly named or something. You can register, and one thing that's really important, you can register custom or synthetic beans and synthetic observers. Those are actually fairly often used in Quarkus. So but custom metadata, which actually are annotations, are like the most often used part of the extension API.
Why I meant metadata, not annotations, because it could be stored in XML somewhere, but the metadata is is always annotation, right? In the end, but
the CDI specification calls them metadata, but in the end they are always annotations.
Okay, and this is problematic for Quarkus and others because you have to do that at build time, and you don't like to use reflection, right? And as I recall, the portable extensions were have to be registered with the service. How to call it? Service locator? No, service locator. The
service loader.
Service loader, exactly. Service loader, which was meta-inf, right? So this was a manifest MF, and you have to read and then instantiate the class. And this was the how the portable extensions were supposed to be registered.
Yeah, that's right. We actually so for CDI 4.0 we designed a new API for extensions, which we called, for lack of imagination, we call them build compatible extensions.
Oh, okay.
So they are also registered through service loader. It's not too big of an issue. But there's like there might be three major differences, but I only remember two of them. So the biggest problems with portable extensions are that, one, they require a running CDI container because they integrate with CDI through CDI events. And CDI events just require a running CDI container, which we don't have during build. So that's one of the problems. The other problem is that the portable extensions API directly expose reflective access to the classes, which we don't want. And we sometimes cannot even do. Like in Quarkus, it would theoretically be possible. We actually had, but we don't want that. We actually had a second implementation of CDI Lite in the works by the Oracle people, which was based on Micronaut and which was executing in an annotation processor. I don't think reflective access would be even possible there. So we had to design, in addition to the new extension API, we actually had to design a new language model API, which was completely reflection-free. So and there might be another difference that I'm not remembering at the moment. So let's skip that.
And I'm assuming it is hard to have portable extensions for Quarkus, because if you're adding types to classes, it is too late, right? It happens in boot time, and the Quarkus has no possibility to optimize the code, right? So what is missing is part of a proxy or whatever, where Quarkus could optimize or generate the bytecode, right? It's too dynamic for build time optimization.
Yeah, that's right. Yeah, that's right. That's the third difference. Your portable extensions can and often do things that need to happen at runtime. Like they can, for example, open sockets, right? Which you can't do during build time.
Yeah, or that doesn't make any sense because
right. So it is often possible, or even sometimes even straightforward, to migrate a portable extension to a build-compatible extension. But for things like that, you have to use synthetic beans, and there's a way to pass some data from build time to runtime, specifically for synthetic beans and synthetic observers. So you can capture some things, or like some configuration or something, in the build compatible extension, and then pass it to the synthetic bean, so that the runtime part has access to it. It's a little bit confusing, but we didn't find a better way.
What I'm thinking about, another possibility would be just to say, if you would like to have dynamic portable extensions, just do it, and Quarkus just treats this as part of the application, right? So this would be, it is not like, you know what I mean? There's not like nothing optimized, and you can do whatever like. It is similar to use reflection by myself inside Quarkus. Then, I mean, you can always do that, right? No one prevents you to load Weld into Quarkus and do portable extensions on top of Arc.
That would be... I don't know if that would work. I know that I wouldn't recommend it.
No, I wouldn't recommend it at all, because as I already mentioned, I actually never implemented portable extensions for business applications. And this is why, for me, you could completely remove this spec. I wouldn't care. But this is interesting thought, So a challenge, so how to do it right. And you could say, if you would like to do runtime, then just go ahead and do it. But it's not optimized by Quarkus. So Quarkus is like it doesn't know nothing about that. It just, you can just have basic dependency injection and open your sockets and do whatever like.
Yeah, honestly, I think there would be a call that there would probably be a lot of conflicts over type discovery. So Weld would discover...
No, this was just an example.
Bean classes
Weld would
were already discovered by R.
Yeah.
This
would be
idea,
bad,
but
right?
Please don't do that.
This would be really bad. What I meant is that the Arc will support this in less strict manner, right? So.
Yeah, probably.
Yeah. But better. You made better choice. So just remove it and let it be, because if no one asks about that, this is just matter for a podcast. This is nice discussions, but yeah. What else? Because what interests me, what if you remember, what were the major 4.0 or 4.1 CDI features?
Well, so for 4.0, the major feature, or like probably the only feature, was the split of core to light and full.
Okay.
And the language model API. I don't remember if there was anything else. We did a few quality of life improvements in 4.0. So we added the startup and shutdown events, so that you can finally react to application startup and shutdown using proper terms. You no longer have to observe the initialization of the application scope, which was used as a proxy to application startup before. You can just observe startup, and the same with shutdown. I think that's... Actually, I have a little bit of a...
Or for one, it doesn't matter. So both are...
a presentation here.
Just, the big...
Yeah, there was... Yeah, so yes. Yeah, one of the... There's a few other smaller things. The lifecycle events, which I just described, we added an instance handle, which is like a tiny thing for dynamic lookup to be able to get to the bean metadata. We added a support for priority on stereotypes. We have removed a few deprecated APIs, and we have changed the meaning of empty beans XML, which is a fairly controversial choice, but we just couldn't make it any other way. So empty beans XML used to mean bean discovery mode of all. It now means bean discovery mode of annotated.
Oh, because to make it Quarkus compatible.
Yes. So those were the things of we added in CDI 4.0. In CDI 4.1.
And you mentioned stereotypes, which is interesting concept we didn't mention in this podcast. What stereotypes for me means is basically almost like a macro. You have an annotation that can put other annotations on it, and then you have just one single annotation. Let's call it endpoint, and it could be request scoped, transactional, or whatever, and intercepted. And if you put on your class, you get the behavior of all the annotations, with which the stereotype is annotated. It's like a custom name, right, for behavior.
Yeah, that's right. You can't actually like inherit all annotations from a stereotype, but you can take a scope. You can take interceptor bindings. You can take the named annotation. There's one more thing I think.
Interceptor, I think, right?
Interceptor bindings, yes.
Okay.
And since CDI 4.0, alternative. Yeah, you can take the alternative annotation from a stereotype.
And transactional also works.
That's an interceptor binding, yes.
Okay.
And since CDI 4.0, you can take the priority annotation from a stereotype.
Why priority? What was the reason, actually?
So the main reason, so I think if you can inherit an alternative status from a stereotype, why shouldn't you be able to inherit a priority? Because like without a priority, you don't have an annotation, you don't have an alternative at all. Like if an alternative doesn't declare a priority, it's not enabled. Like in CDI full, you can enable an alternative in Beans XML. We don't have that in CDI Lite. So the only means of enabling an alternative is through a priority. And if you can't inherit a priority from a stereotype, then it doesn't make any sense to inherit the alternative status.
Okay, stereotypes supported alternatives,
yes.
And you changed the Beans XML meaning, so you had to add to allow priority. Otherwise, you will have to remove, or it will be not backwards compatible, right?
It would be backwards compatible. It just wouldn't make any sense to have an alternative status on a stereotype.
Yeah.
You would still be able to enable that alternative directly on the place that you used the stereotype, but like honestly, the canonical example of a stereotype in the specification is mock, which just like probably not the best name, but it's fairly often used. A mock is an alternative, but to be able to actually use it, you have to enable that alternative. So you kind of have to put the priority over there, right? So I think that's the canonical example for adding priority support for stereotypes.
Okay.
So I think I mentioned all of the improvements in CDI 4.0. In CDI 4.1, the biggest improvement is an addition of method invokers, which is like not at all useful for application builders. It's exclusively meant for extension authors. But it's like fairly powerful. And deceptively simple also. It's a way to, like in your extension, you can say, create me an invoker for this method of this being. Right? And what it gives you back is an implementation of the invoker interface, which has a method to invoke the method. So invokers allow CDI extensions to indirectly invoke application methods. In like CDI full, when you register an invoker in a portable extensions, you get an invoker directly. In CDI Lite, in a build compatible extension, when you register an invoker, you get an invoker info that you can pass to a synthetic bean, and that synthetic bean will at runtime obtain an invoker.
And this is why Invoker was introduced to allow the runtimes to generate bytecode, right? Because they have now something.
Yes, sort of. So in CDI 4.0, we have a mechanism to pass data from the extension to a synthetic bean, which allows transferring data basically in a limited form, but data. With invokers, we can also transfer behavior. You can say.
Okay.
But it's really more about CDI frameworks not having to use reflection or, in Quarkus case, bytecode generation to support invoking application methods, which is like the only or the primary use case for frameworks is to invoke application methods, right? So we have that, and we have a few quality of life improvements as well. Just looking at it, the invocation context API, which we already mentioned, now has a method to obtain interceptor bindings for the intercepted method. Like that's been possible since, well, forever basically, using a how would I say that, a non-portable API to look up the interceptor bindings from the context data map. But now there's a method for that directly, because it's like it's so immensely useful, and it hasn't been there for practically no reason.
All the features covered now. Major features. Or yeah.
If you want another major feature, which I think is also interesting, is with CDI 4.1, you can declare priority directly on producers. It wasn't possible before. And producer methods and producer fields inherited the priority from the declaring class, which honestly is like, I think it's been like that only because the priority annotation had had the target annotation that didn't allow fields and methods. So that's possible now, and producers can declare their own priority.
So the target was forgotten.
I guess that's probably the case. The priority annotation comes from Jakarta Common Annotation Project, Common Annotations Project. And I guess it just wasn't possible to interact with those people under the Java EE umbrella, probably. I don't know.
But it's interesting, right? Interesting. There's small things,
Yes. Yeah. Now that that's in Jakarta, it's like much more streamlined. We're just able to submit a PR and get that merged. So yeah, I think that's most of it.
So what I really appreciated by the entire CDI or dependency injections, how well it was integrated to the application programming model of application servers, and Quarkus, of course, as well. So what I mean by that is, if you have one interface or just one class, you don't need an interface. If you have just class, you can inject the class. You don't have to perform any configuration. It just works. If you have an interface and a class which implements the interface, you can just inject the interface, and the runtime will find out the one and only implementation and inject that. So if you have two implementations, you get ambiguous dependency error. So it means the runtime notices that and says, okay, there are two, and now do something about that, because I have no idea what to inject. And the cool story is, now in Quarkus, you get this at build time. So if you run Maven, on other applications, we got in runtime, because they deployed the entire thing at runtime. They had to. So this is one of the benefits of build time. How to call it? Deployment. Build time deployment, maybe.
Yeah. In CDI specification, we use the term deployment time.
Deployment time.
Which like in build-oriented implementations means during build, while in runtime-oriented implementations it means during the application deployment.
So it means convention of a configuration paired with dependency injection. This is what got me interested because if you build a very simple application, let's say JAX-RS endpoint with a single class, you had two classes and one annotation, right? You had the JAX-RS endpoint and your, let's say, class which did some work, and you could inject this class with @inject, and you were done. No XML, nothing. But you can extend at any time. So this is the interesting part. So you're not at any time. You don't have to over-engineer your application in advance. You can start simple and enhance on the go. So this is actually the interesting part. And this is why I never got the idea why Juice got so popular, because Juice was not convention over configuration. Means it was hugely popular, and I asked many developers and architects, but why you like it? Because there's an interface implementation, and there was, I think, module binder, I guess.
Yes.
This was the and you had to implement a third class, and you had to say, as I remember, interface bind to implementation via context. So I liked the DSL. So the way how it was configured was genius. But the point that I had to configure this, I didn't like at all. And I never got a response, but it's still very, very popular. So I appreciate the Java J2E, Java E, Jakarta E, and Quarkus way or microprofile way of doing that. And what also interesting, I have the feeling in Quarkus case, if you use dependency injection, of course there's no reflection, and Quarkus generates bytecode at build time. But I think the performance is the same in CDI. Let's put the scopes aside. Let's say I have application scoped with @inject just and dependent scoped. So bean, @inject, and dependent scopes. I would say the performance is identical, if not identical, to writing by hand a static reference to the beans, because it is just associated at build time, right? So there is no runtime behavior.
That's right, with the exception of client proxies.
Yeah, but
right. If you have a normal scope, you have a client proxy which has to look up the right instance of the bean.
Yeah, but the proxy doesn't use reflection. It just looks up in a hash map reference.
Yes,
this is what this would be the overhead. So it is negligible, I would say. And what you already covered with the singleton, at singleton, there would be actually no overhead because there would be no proxy.
Yeah, that's right.
Yeah. And if you think about this, it is outside Quarkus or similar runtimes, and a Micronaut or similar, but outside such, how to call it, build-oriented runtimes, you would have to use reflection, or you will have to generate your own bytecode. So there's no other way to do that. Yeah.
Yeah, that's right.
Yeah. Perfect. We covered a lot of ground. Any things which I forgot to mention, or any topics you are interested?
I don't think so. Yeah, I think we mentioned most of the CDI improvements that I have been around for
5 years, almost. You told me.
Yes, it will be 5 years. I think in this summer. I think it was summer 2020 when I became involved in CDI 4.
Okay.
Yeah, I think there's maybe one more thing. There's CDI 5 coming, but there's not much in the works. The only reason why it's going to be CDI 5 is that we're making a breaking change, and we are removing 2 methods from the bean manager interface.
Oh, so this is a cool marketing trick. You're removing two methods. And
yeah. Those 2 methods are like, I'm not exactly like 100% sure, but I'm fairly sure that no one's ever used them in applications. They're meant for application servers to integrate CDI with the expression language. And they were put on the bean manager probably just because there was no better place to put them.
Okay.
So we have created a sub interface, put that into a separate module, and those two methods are in a separate module and will be removed from the bin manager API.
So it means we are all looking forward to the 5 release, right?
Yeah. The interesting part about it, or like the thing that might be interesting for some people, is that the CDI API will no longer depend on the expression language API.
Mm-hmm.
So there's like one less dependency.
But the expression API was actually really interesting, because the expression API, as I remember, introduced lambdas before Java had them.
Yeah, that's quite possible.
The expression language was really interesting. So yeah, but it's not needed in CDI at all. But in other areas could be interested, right? So
yeah.
So perfect. What was the name of the cookies again? So this is
the cookies. Zimovské hady.
Zimovské hady.
Yes.
Very good. And you had trouble with the right sizing of the cookies, so you had to micro snakes, but you were able to deliver the Pythons. But as the task to listener to do some research whether it is available in your area, the cookies. It was really nice to chat with you, and I would like to reinvite you back, to talk how hard was it to remove the 2 methods in
It wasn't too hard. It just took a lot of time. Yeah. We decided to do that in CDI 4.1. So we added one module, added the sub-interface there, and in 5.0 we just removed the methods from the bin manager API.
Okay.
And we removed the dependency from the CDI API module.
Thank you. Where people can find you, on LinkedIn, whatever, Twitter, Blue Sky.
Yeah, I'm still an asocial person. Mm-hmm. I'm on LinkedIn. I think you mentioned me in the previous post about the video with the first video with me. Mm-hmm. I think you mentioned my LinkedIn account. Other than that, I'm on GitHub, and that's probably it.
Ladicek, right?
Yes, that's right.
Yeah. Cool.
I have been on Twitter, but I left a few months ago, or half a year ago, something like that. Mm-hmm. And it wasn't bearable anymore.
Yeah.
And since then I haven't moved to anywhere, just because it fits me. It's actually a good thing to not be on any social media. I have more time to read books.
And for cookies.
And for cookies, but just for Christmas.
Thank you a lot. It was a pleasure.
Thank you. Thanks for having me.